Let's talk about the density of gases and measuring them. Different gases, we know, have different densities. Why is this important? How do we measure densities quantitatively? We have a qualitative understanding of them, depending on, for instance, whether they float in air. What causes the densities of different gases to be different? Is it that denser gases have more particles per liter? Or do gases have the same number of particles per liter, but those particles have differing masses? Why is gas density important? Well, ask the folks on the Hindenburg. You may wonder why the Germans and others used hydrogen, this so-called lighter-than-air gas, to lift their dirigibles. Why didn't they use helium, which doesn't burn? This is something you might go into the history books to ask. And you might also watch a Discovery Channel video that was produced at Southwest Research here in San Antonio that showed what the current thinking is on how the Hindenburg tragedy occurred. How do we measure gas density? Well, first, we have to find the mass of a given volume of nothing, that is, of a vacuum. We can use an evacuated flask or a syringe with a plunger that has a hole drilled into it for a nail to keep the volume the same. Then we're going to put the same volume of gas into the flask or syringe and find its mass. Of course, the difference between the empty container and the container with the gas is the mass of the gas alone. This is the arrangement that you're going to use. You'll notice that the nail goes through the plunger stem of the syringe, and you'll also notice that that nail has to bridge the hole in the syringe that the plunger fits through. Always have that happen so the nail doesn't get pulled into the syringe. Now let's do the experiment. You're going to quantify the relationship between the densities of oxygen, natural gas, and probably carbon dioxide and maybe even other gases. Once you are finished with that, you'll come back to this video. Remembering your 3 investigation gas lab, what must you control when studying the density of gases? Well, you have to make sure you're always starting at the same temperature and pressure, and that you always have exactly the same volume of gas. Now you can turn off this video and go do the experiment. You've come back with some data, and from a prior high school work, we have specimen data for you to look at. For 50 milliliters of gas at 25 degrees Celsius, we have oxygen, air, carbon dioxide, methane, and helium, and you can see the difference in these masses. Please note we used a milligram balance for these experiments. Now the gas densities in grams per liter come out to the numbers you see here. And for instance, you see carbon dioxide is 1.80 grams per liter, whereas helium is 0.17, about 10 times lighter, 10 times less dense. We can use hydrogen as our standard, and some did that in the early years, hydrogen being the smallest, and just call it 1. And so the relative mass of hydrogen is about 1/20th that of carbon dioxide. The relative mass of oxygen is in the vicinity of 15 or 16 times greater than hydrogen. But later on, for a number of reasons, scientists decided that oxygen would be a better standard, and in time we used oxygen at 32 as our relative mass standard, giving us, for instance, methane at 16 and carbon dioxide at 44. You probably saw that the density of methane in your experiment was about half that of oxygen. So we can prepare a table of relative masses of all the gases. Now we still don't know what to do about this, or if it has anything to do with the mass of the particles, but it gives us a relative mass scale. What causes the difference in densities? Well, there are really only two possibilities, or combination of two possibilities. The first is the denser gases might have more particles per liter. That is, say carbon dioxide, which is 11 times more dense than helium, might have 11 times the number of particles of helium in the same container. That's one possibility, and think about that and convince yourself that that could be the explanation. Gases, however, could have the same number of particles per liter, but the particles' mass might be different. In this case, carbon dioxide would have particles that are 22 times heavier than hydrogen and 11 times heavier than helium, but the same number of particles. Now, you can make a hypothesis as to which of these is true as you go into the other investigations, and you should make a hypothesis about that. We can solve the riddle, but first we have to count the number of particles in equal volumes of two gases at the same temperature and pressure. If one of the gases has a lot more particles than another, then we come down on hypothesis number one, more particles. On the other hand, if we count and find that the number of particles is the same, then we know that the denser gases have denser or heavier particles, particles that are more massive. So these are the contenders, more particles or more mass. How can we tell the difference? Which one will win? Well, let's try to compress both gases, both the denser gases and the not so dense gases. And let's see if they compress differently. We might think if the denser gas is harder to compress than the gas of low density, that seems to support the first contender, more particles, because the carbon dioxide, for instance, would be pushing back on our compression more than the helium. We can see what would happen by doing the investigation. And so we're going to do a Boyle's Law investigation next and look at the compression curves for both gases, both kinds of gases, both the denser gases and the not so dense gas.